Right. Continuing with OSPF point-to-point networks. Here we are going to discuss, let me see, the election process. Okay, by default, Cisco routers elect a designated router and a backup designated router on Ethernet interfaces, even if there is only one device on even if there is only one other device on the link. Right. What are we talking of here? Ethernet, we discussed this, right? Ethernet interfaces, those are multi-access networks. Ethernet interfaces. Ethernet links are multi-access, right? And we talked of serial links as point-to-point. Serial point-to-point. Ethernet multi-access, right? So if we have a network like our reference network, this one, our reference network, voila. As you can see, it is using Ethernet links on Ethernet interfaces. It means even if, by definition, when we started OSPF, we defined a point-to-point OSPF network, the one which there is only communication between two devices, in this case, two routers. So this is a point-to-point. Let me use P2P. This is a point-to-point because on this link here, this router is only communicating with this router here. It's a point-to-point. But the problem is, on a point-to-point communication, we used a multi-access link. An Ethernet link, this link here, this is a multi-access link. Therefore, it behaves as a multi-access link. This is a point-to-point, but using a multi-access link. If we wanted this to be purely a point-to-point, we could have used a serial link like this instead of using an Ethernet link, right? So with the Ethernet link acting as a multi-access, what is being demonstrated here is you see that it will have network type broadcast on it. The Ethernet interface, it will have network type broadcast on it. Why? Because it is a multi-access link. And that needs to be changed. It needs to be changed because the network we have here is a point-to-point. And how do we change that? We use the OSPF network point-to-point on all the interfaces where you want to disable the DR or BDR election process. Let me go back. All Ethernet interfaces are multi-access by nature. Even if you have a point-to-point communication, if you have a point-to-point communication and is on an Ethernet interface, what does it mean? There will be in this case, there will be a DR, BDR election. Even if you're on a point-to-point, it's a bit confusing. Where we need a DR election is where we have a multi-access. A multi-access in OSPF, I think a multi-access, we had a switch and we had routers here. This is a multi-access in OSPF, right? This is where we need designated routers and backup designated routers. In a case like this, we do not need a designated router. But if the link we are using is an Ethernet, by default, it will behave as a multi-access. Therefore, it will initiate the DR, BDR election, which does not make sense, but it is an Ethernet interface. It will do that. So to disable that, it needs to be disabled. One, you use this command. You command the link to act as a point-to-point, IP OSPF network point-to-point. So on the interface, you configure the IP OSPF network point-to-point. And if you show the IP OSPF interfaces command, if you check again after configuring that command, you can see right here, it is now changed to point-to-point from broadcast. So if you show the interface and you see it's a broadcast, it means it is it acts as a multi-access. There is going to be a DR election. But if your network, you know it's a point-to-point, you need to disable that. So that is where this command comes in. Right. Let's look at loopback interfaces and point-to-point networks. All right, here we are looking at how we can use a loopback interface as one, as a host route, and two, as a network. A loopback interface, networks are not an loopback interface. You can use it to, okay, as you can see here, use loopback interface to provide additional interface for a variety of purposes. Number one, we can use it router ID. We can configure a loopback interface to shandisa the address as the router ID. That is number one. Two, let's say you want to simulate a network. You want to simulate a network on that loopback interface. This is my router. This is my loopback interface 0. Another router there. I want to simulate this as a network. How do I do that? I configure the loopback interface as a point-to-point network. You go into the interface loopback command, configuration mode, interface configuration mode. You enter the IP OSPF network point-to-point command. And what that means is this loopback will now behave as a local area network. And what is evidence of it behaving as a local area network? If you go to the neighboring router, in this case, let's say if you go to R2 and you show the table, the routing table of R2, you will see the address of the loopback interface being advertised. Only addresses that advertise in the network, in the routing table, are addresses of networks. Addresses in the routing table are addresses of networks. In this case, in the first case, where it was not being treated as a network, you could see it was being treated as a host route, /32. If you want to manipulate it and configure it as a network, this is the command for it, IP OSPF network point-to-point, and this is the change. It now has a /24. A /24 is now behaving as a network instead of behaving as a host route. So this is just demonstration of how you can use the loopback interface for a variety of purposes. Purpose number one, if you configure it as a host route, therefore it behaves as a host, and that address can be used maybe as the router ID if you do not configure the router ID manually. That is one. Two, you can use the loopback interface to simulate a local area network. A network and a host are two different things. This differentiates a host and a network, that command. And voila, from the routing table, we now have a network being advertised. Multi-access OSPF networks. Right, OSPF networks. Voila, there we have an OSPF network. As you can see, In a multi-access network, we have broadcasts. In a point-to-point network, we do not have broadcasts. There is communication between two routers. So this is P2P, communication between two routers. This is multi-access, two different things. The difference is in P2P, if router 1 communicates with router 2, there is only communication between these two devices on this link, router 1 and router 2. There is nothing else but router 1 and router 2 messages on this link. So router 1 sends its hellos, how are you? I have this router ID, I have this router ID. Okay, you need to send your DBDs. I send my DBDs. Messages are being exchanged between these two routers. But in a multi-access, what happens? If a hello is sent, it needs to be sent from R1 to R2 to R4 to R3. That's a broadcast. If an update is to be sent, it is to be sent from R1 to R2 to R4 to R3. That is a multi-access network. And in OSPF, that's why we have a DR election, designated router. So with a designated router, we have only one router which is chosen. So when we want to send our hellos, let's say our updates or our advertisement, if this is our DR, we send our updates to this PC, to this router here, instead of broadcasting. Then the designated router chooses to broadcast those updates or advertisements. So this basically summarizes what is a multi-access and what is the difference between that and a P2P. So in P2P, no need for a DR, but here in multi-access, there is need for election process to identify the designated router and the backup designated router. Right, what's written here? Another type of network, multi-access, are unique in that one router controls the distribution of LSAs. Right, that one router which controls the distribution is the designated router. The router that is elected for this role should be determined by the network administrator through proper configuration. Proper configuration done by the administrator to determine that is choice of the router ID. The highest router ID becomes the designated router, and this router ID is manually configured. So when we talk of proper configuration, is the network administrator, we're talking of the network administrator choosing wisely which router to give the highest router ID. OSPF designated router, right? In multi-access network, OSPF elects a DR and a BDR responsible for collecting and distributing LSAs. We know that. The DR uses the multicast, this address, right? The designated router, those addresses are very important. The designated router, it uses the multicast 0005. So after the designated router has received all the updates from other routers, it then sends a multicast 224.0.0.5 to every router in the OSPF so that it receives the updates. Right? There is another address here, this one, 224.0.0.6. Right, let me put it this way. We have a network. Right, there is our multi-access network. Right? And this is our DR. We have elected this as our DR. So let me introduce a couple of terms there. I think they will be introduced in the next slide as well. If this is the DR, we will have a BDR. Let's say this becomes our backup. What is not a DR or a BDR, it becomes a DR other. All right? That is our network. right? So if a DR other wants to send an advertisement, it sends an advertisement using this multicast address, 224.0.0.6. This multicast address is destined for all designated routers. And what are all designated routers? All designated routers are the DR and the BDR. So a message with a multicast address like this, it is destined for these two here. So a DR other uses this address to send its advertisements. And when the DR receives the advertisements, it collects all the advertisements. Let's have another DR other here. So the DR collects the LSA from this DR other and another LSA from this DR other. It collects all of them, multiple routers. It consolidates them, and it needs to send an update to every other router now. And when a DR sends a message to all the routers in the OSPF network, it uses this address. The difference between those two addresses, one is destined to the designated routers, which is this one. The other one is destined to every other router in the network, which is this one right here. I think basically this is what this slide discusses. So it's important to take note of these addresses. In a typical exam, you will be asked about these addresses. Identify what are these addresses. So this one is for designated routers. This is for all OSPF routers. Okay. Right. Reference topology. Right. This is the reference topology we are going to be using for configurations, a multi-access network. We can see our router IDs here. 111.222.333. And from what we've learned, the designated router is the highest router ID. That's why this was chosen as the designated router. The BDR is the one with the second highest router ID. That is why this one was chosen as that is why that one was chosen as the backup designated router. And this one is the other. It is not a designated router. It is not a backup. So this is the network we are going to use as our reference. Let us see how we are going to configure it. Verifying OSPF router rows. Show commands. It's very important to understand how show commands are used in a network. Very important. Show commands. I will repeat this again and again. So if we show IP OSPF interface brief, we will show and verify the rows of routers in the network. And what are the rows we are talking of? What is the DR? What is the BDR? And what is the DR other? Those are the rows of OSPF routers. So R1, if we go to our reference, what is R1? R1 is a DR other. R3, okay, let me see. R1, okay, right. Here, R1 is a DR other. Okay, oh, let me write it right here. R1, Hebana. My pen is no longer functioning. Let me see. All right. Okay. R1 is a DR other. R2, let me see. This is R2. R2 is a BDR. And R3 is our DR. So with verify OSPF router rows, show IP OSPF interface, what do we see? What we see is R1 here, is in the state dr other. We can also see the dr ID, which is 333, which is the ID of router 3. We can see the BDR ID, which is 222 for router number 2. So all that information, you can see it from the show commands. If we go to router number 2, router number 2 is the BDR. So its state is BDR. And you can see the router ID of the designated router 333 of the DR other as well. 111 333 222. Where is 111? The DR other adjacent neighbor. Okay, it's treated here as an adjacent neighbor. There is no DR other here. R2 is the state BDR. If we go to R3, the state is now DR. Right? So the show IP OSPF interface command, it shows us the roles the routers play in the network. What is the BDR, what is the DR, and what are the DR others? Making use of the show commands. Verifying adjacencies. Show IP OSPF neighbor. This is how we verify adjacencies, right? Neighbor. We have three ways to show adjacencies between two routers. One is a full DR other. So if we have a DR and a DR other having an adjacency, and you show the neighbor IP OSPF on the DR, it will show you it is in full DR other mode. If you go and you show the command here, it will show you a full DR, meaning the DR other is in full adjacency with the DR. From this side, you get number 1. From this side, you get number 2, basically. That is all that we mean. And with the other one, full BDR, let me see. Right, with full BDR, this is a router which is fully adjacent, with an indicated BDR neighbor. Right, let me see. With that one, we have a DR other and a BDR and a backup designated router. So if I show the neighbors from this side, that's where I get a full BDR. That's my neighbor. Lastly, the other one, the two-way DR other. This is when a DR other is adjacent to another DR other, not adjacent. It's a neighbor DR other. That's where we get a two-way DR other. So when the non-DR or BDR router is a neighbor relationship with another non-DR or BDR router, these two neighbors exchange hello packets. Excuse me. All right. So these are adjacencies that we have. Understanding what they are begins with understanding the roles: DR, BDR, and DR other. Now, if you have DR and DR other, so this is a router, it's a neighbor like this. If you go and show this, you get number 1. If you go and show neighbor from this end, you get number 2. If you have a DR other, okay, it's up there. If you have a DR other and a DR other, if you show the neighbor from this one, you get number 4, DR other and DR other. And now if you have lastly a DR other and BDR, being a neighbor with BDR, and you show from this side, you get number 3. In practice, I think it's easier explaining in practice. We'll do that. Let me see. Right. From our reference, we are showing the IP OSPF neighbor from ARA2. From ARA2, what is ARA2? I think ARA2 was our BDR. Let me see, where is our reference? Our reference here, ARA2 was our BDR. Okay, let's see what it shows. Right, ARA2, we have address 111, that's our neighbor. 111 is a full DR other, because 111 is a DR other. 333 is a full DR. Why? Because 33 is our designated router. These are the states that we have from the show IP OSPF neighbor. Basically, that is what it's saying. If you go to, okay, there are no other examples there. Let's say, let's give ourselves, let's go to ARA1 and show IP OSPF neighbor. What will it look like? So we have the neighbor ID here. We have 2, 2, 2, 2. We also have 3, 3, 3, 3. ARA1 is a DR other, right? Then 2 is a BDR. So the state here will be full with this one. The state with this neighbor, ARA1 and this neighbor. And with this one, it will be full. For DR. So if we were to show the neighbors from ARA1, this is what you will get. Because the relationship with this 222 is full BDR, with this one is full designated router. Default DR, BDR election process. Right. Here we'll discuss the election process of the designated router and the backup designated router. In short, we've been discussing this from module number 1, I think. How is that determined? Number 1, the routers in the network elect the router with the highest interface priority as the designated router. 2, the interface priorities are equal, then the router with the highest router ID is elected as the designated router. If we don't have a router ID, then we have the loopback interface, then we have the IP addresses in order of precedence. So here we've only added the interface priority value here. So the router with the highest becomes the DR. If the priorities are the same, then we look at the router IDs. The one with the highest router ID becomes the DR. The second becomes the BDR. I think it's simple to explain. So summarizing, number 1, we are now looking at the priority. First, priority first, that's a value between 0 and 255. Then number 2, we look at the router ID. What is the router ID? It can be manually configured. It can be a loopback interface. It can be an IP, the interface of an IP. Okay, right? Election process, priority first, router ID next. DR failure and recovery. What happens when the designated router fails? That's why we have the backup designated router. After the DR is elected, it remains the DR until the following event occurs. The DR fails, OSPF process on the DR fails or is stopped, multi-access interface on the DR fails or is shut down. If DR fails, BDR automatically is promoted to DR. Very simple to understand, right? IP OSPF priority value. This is how you can manipulate the election process. Let's say we have our routers here, our routers there. Okay, this is not multi-access. Let's have a multi-access there. Let me see. Okay, so instead of relying on the router ID for choosing what is the BDR, I can come to this router. Let's say this is router 1, router 2, router 3. And the ID here is 3333. Here is 2, here is 1. It means from this, I know this will become my DR from the router IDs only. But I can manipulate that process and change the priority values. I come to this router and I say priority is 255. What it means, even if the router ID is lower than this one, it has a higher priority. It will become the designated router after the election. So this is a way of manipulating. Even if the router IDs are there, you can manipulate which router to choose as the designated router. All right, in summary, let me look at this. A value of 0 does not become a DR or a BDR. A value of 1 to 255 on the interface makes it more likely that the router becomes the DR or the BDR. If you want it to be not more likely or anything, just use 255 because this is the highest priority value. And how do you change that value? We have the command right there, IP OSPF priority value in the interface configuration mode. Configure OSPF priority. Voila, there we have OSPF the priority being configured. Another important thing, for it to take effect, we have the clear IP process again. Clear IP OSPF process to reset, to reload the whole OSPF process. Even if you've changed this, if you don't have the clear IP OSPF process, the change will not take effect until you have cleared the process or you've reloaded the router. Modifying single area OSPF, right? We talked of the cost. We talked of it being equal to the reference bandwidth over the interface bandwidth, right? Now, to manipulate that, we need to change the reference bandwidth. To manipulate the cost, there is need for changing the reference bandwidth. And how do we change that? We have the auto cost reference bandwidth command to change the calculation of the cost. If you change the cost, it means you have changed the way the SPF algorithm will calculate the cost of the path. Then you've changed how routes are chosen. Basically, that's it. That's why we are changing the auto cost reference bandwidth with that command. You can also manually set a cost using that command. So everything we are doing here is sort of manipulation. To manipulate one, the election process of the DR, here we are manipulating the cost. We know by default what the cost is. By default, the cost, for example, for a fast Ethernet, I think is 1. Is 1. But we want to manipulate so that it does not become 1. How do we manipulate that? We change this value here, the reference bandwidth. All right, let's see. Adjusting the reference bandwidth. We'll probably need, or I did it in module 1. I hope I did it. The meaning of this, I think I'll add an extra session. How to find, let me see. Okay, draw. How to find what is the cost of fast? What is the cost of a giga Ethernet link? What is the cost of 10 gig, etc., etc.? How to calculate that? I'm not so sure if I did it in the previous module. Probably I'll do it in the last session. Right, let me see. Adjusting the reference bandwidth. Right, so we have two commands which can be used to manipulate that. We change the we change the reference bandwidth, number one, or we change the cost itself using the IP OSPF cost manipulation. Auto adjust the reference bandwidth. Okay, it's there. It's there. Okay, the calculations are there. Right. By default, we have the auto reference. Just a minute. Let me see. Just a minute. Okay. Working at home problems. All right. I can see how many minutes. I can see 1 minute left. Let me just have a last session. I think there is a lot to talk about those bandwidths, how the cost is calculated. I thought I had done it before. I'm realizing no, I hadn't done it. So let me add this one, start another session. I think that will be the third one and the last one.